Now in one of previous videos we have learned that there are 6 types of graph data structure, which are unweighted undirected graph, unweighted directed graph, positive weighted undirected graph, positive weighted directed graph, negative weighted undirected graph, and negative weighted directed graph. Now when we implement BFS for shortest path problem, it works only for unweighted graphs. So as you can see from this table that we have put OK only in case of unweighted graph. So if our graph is weighted, in this case, BFS method cannot be used for single source shortest path problem. Now to understand the reason, let's see an example over here. So we have already known that BFS explores a given graph only in breadth way. So this means that we are visiting the nodes level by level, and based on that we are finding the shortest path in this case. So if I run the BFS method for this graph over here, first is going to visit A, then we are going to continue to the next level. So when we go to the next level, in the next level we have B and C. So when we reach this level, we are going to mark these nodes as visited, and we are going to update the parent of these nodes to the current node. Now the current node is A, so this means that when we reach the B, the parent of B will be updated to A, and parent of C similarly will be updated A. So this means that to go to B, we have to go AB, and to go to C, we have to go AC. So these are the shortest paths from A to B and from A to C. Now if we continue to the next level, in the next level, we are going to come from B to D. So this means that the parent of D will be updated to B, and similarly the parent of E will be updated to B. So this means that from A to E, the shortest path is like this. So we have to go to B, then we have to go to E. So because in E we are coming from B, and to B we are coming from A. Now similarly, if we want to go to from A to D, we have to go to B, then to D, because this parent is B and B's parent is A. Now if we examine these paths over here, we can see that the cost of going from A to D is in this case 10 plus 30, which is 40, and the cost of A to E is 15. But here in this case we can easily see that there is another alternative way from A to D, which is cheapest than the road that we found in this case. So in our case, in case of BFS algorithm, the road shows that we have to go from A to B, then we have to go to D, and the cost is 40. But an alternative road is like this. So we have to go to A, then we have to go to E, then from E we can go to D. Now in this case, the cost will be 10 plus 5 plus 6, which is 21. In this case, you can see that the cost of this road is cheaper than the road that we found in case of BFS method. So this means that if the graph is weighted, in this case, BFS method might ignore some edge. So in this case, you can see that this edge between D and E is ignored when we are finding a shortest path from A to other node. So that's the reason that we cannot use BFS method for weighted graph in case of single source shortest path problem. Now with this example, hopefully you have understood why we are not using BFS method for weighted graph in case of single source shortest path problem. Now in the next lecture, let's identify why we cannot use depth first search method for single source shortest path problem. So see you in the next lecture.